So in today's video, we're going to look at the chi-square test for association. What this looks at, it's our last topic that we're going to look through. What this looks at is our two different variables, okay? They're going to be two different qualitative variables, okay? For example, you could do gender and type of music, okay? That's two types of qualitative variable. Each one has multiple different things that it can be. So gender can be male or female, type of music, you can have country, jazz, classical, etc. Okay. What we're going to look at is the link between these two qualitative variables. Are they independent? Are they dependent? Does gender affect the type of music that people like? Okay. So that's the type of thing that we're going to look at with this chi-square test for association. And the way that we do this is by using something called a contingency table. Okay. What a contingency table does is it tells you the number of people that fall into these categories. So for example, if you had a contingency table for gender and type of music, you could have male, female, and then let's just pick three types of music here: country, jazz, and let's say pop. Okay, so three different types of music, and we've got these two different genders. So what we're going to do is we're going to write in this table how many people are male and like country music. So however many people there were, you can write that in there. Then you write in how many people were female and like country music. Same with jazz and same with pop. So a contingency table tells you how many people fall into these categories. So you'll have how many fall into male and jazz, how many fall into female and pop, etc. Okay? So it tells you the link between the two variables. Each one of the variables that you have, each one of your qualitative variables, in this case gender and music, each one of those variables has multinomial distribution, okay? There can be two or more outcomes, okay? So in the case of music, you could have 10 different types of music. So it's a multinomial distribution, okay? Because there are multiple different outcomes here. So again, what we're going to do this time is to run a hypothesis test to see if these variables are independent or dependent. Whenever you do this, your null hypothesis always suggests independence. Okay? We're going to assume that these variables have nothing to do with one another until proven otherwise. So H0 is always that the variables are independent. And the alternative is that they are dependent on one another. Okay, in my previous example, that would tell me that gender did affect the type of music that people liked. Okay, so that is always the case with these. Okay, once you have your null and alternative hypotheses, you could do this the long way and run one of these hypothesis tests. Okay, so you could then write down what your significance level alpha was, okay, and then you could go ahead and find your test statistic. Now, the test statistic in this case is not an easy thing to find. It is actually a very, very awful looking formula. However, the calculator will do this for you, okay, so don't worry too much about this. I will write down what the test statistic is. We call it chi-squared, again, is the test statistic. And I will explain to you what this actually says. But as I said, you're not going to have to use this because your calculator will do all of this calculation for you. Okay. What this says is very much like the chi-square test statistic that we looked at last time. What this does, bearing in mind we now have two different variables that we're looking at that we want to compare to one another to see if they are independent or dependent. Okay? This Nij that is here, that is the number of people that fell in that category in row I, column J. Okay? So if we go back here, it would be the number of people that were in, if you had N 3 2, okay? If you had N 3 2, that would be the number of people that fell in row 3, column 2. So it would be the number of people in that particular cell in the table, okay? So each one of those Nij's is just the number of people in row I, column J in that table. This Enij is the expected number of people to fall into that particular cell. So we observed that there were Nij people in that cell. So however many people fell into that cell, that's how many people there actually were. But how many did we actually expect to fall into that cell? Okay. The way that that is actually calculated, again, you're not going to have to do this because your calculator will do it for you. But whenever you do Enij, so the number of people that you expect to fall into the cell Ij, row I, column J, okay, it's always the total number, okay, and then it would be the total for row I divided by that total times the total in column J divided by the total. So total is the overall total number of people, okay? Then it would be the total number in row I divided by the absolute total times the total in column J divided by the whole total. So what that tells me, let's go back again. When you did this table, okay, I could add up all the people that fell into this row, okay, and the total for that row I would go here. Okay, in this case, it's actually the total for row 1. Then for each, you could do that for every single row. You could add up the total number of people that fell into that row, both male and female, okay? Then you could do the same for the columns. You could add up all the males that were in this, so this would be the total for column J. Okay, you could add up all the people that fell into this column, so all the males that liked any type of music, and you could do the same for the females, add up all the females, and that would be a total that would go here. So what you do, and over here would be the absolute total. So you could add up the total of all the rows, or you could add up the total of all the columns. It would come to the same number. But what you're going to do is you're going to take the total and then multiply that by the total of that particular row over the total, multiply it by the total for that particular column divided by the total. So the expected number of people to fall into a particular cell is given by that number. As I said, you are not going to have to calculate that, but it will ask you on Hawks what the expected number for a particular cell is. So you're going to have to know where to recognize it, but you don't actually have to go ahead and calculate it, but I'll show you how to do that in a minute. So as before, you're going to take that number in each cell minus the expected number for that cell. Then you square it and divide it by the expected number for that cell, which scales it back again, exactly like we did last time. And you're going to do this for every single column and for every single row. So what I'm doing here is I'm adding up these terms for each column and for each row. So C is the number of columns, R is the number of rows. Okay? So that will give you your test statistic. Then what you can do is you can compare your test statistic to the critical value. Now the critical value, very much like the last chi-square one that we did, okay, is going to depend on your significance level and your degrees of freedom. Whenever you do a chi-square test for association like this, your degrees of freedom is the number of rows minus 1 times the number of columns minus 1. So in our case here, I would have the number of rows minus 1 would give me 2. The number of columns minus 1 would give me 1. Multiply those two numbers together, I get 2. So I would have 2 degrees of freedom in this case. So when I looked up you're going to look up the critical value in the table if you need it, okay? When you look up the critical value in the table, in that chi-square table, you need the significance level alpha and you need the degrees of freedom, which is given by this, okay? So then once you've got all of this, you have your test statistic, you have your critical value, you can go ahead and you can either compare your test statistic to the critical value, or you can compare P, which you'll get from your calculator, that P value, to your significance level alpha. And very much the same way that we did in 16.2, you are either looking for your test statistic to be greater than the critical value. So that gives me that my test statistic is greater than the critical value. Or, as always, you can look at whether the p-value that you get for your calculator is less than the significance level alpha. And in both these cases, what I would do is reject my null hypothesis. So it's exactly the same thing that I would do as in 16.2. So I'm either looking for the test statistic to be greater than the critical value or p to be less than alpha, and then I would reject my null hypothesis. Any other values that I get, I would fail to reject the null hypothesis. Okay. If you look at page 3 of my notes on the Google Drive for chapter 16.3, I have an example on there. I actually did this the long way round, but I will show you the short way on the calculator. Okay, so if you look at that example, it gives you this table, and they're studying the relationship between salary and gender. So we have 316 people in this study. They've got a certain amount of male, a certain amount of female, and they've taken different salary categories. Okay, so they've split up the salaries into categories, and they want to conclude whether the salary and gender are actually dependent or independent on one another. Okay, so I'm going to take, in this case, the significance level. If you actually went through this problem, they tell you, but the significance level that is used is 0.01. My null hypothesis would be that salary and gender are independent, and my alternative would be that they are dependent. Okay. Now they give you a table of the number of males and females that fall into each one of these salary categories. Okay. What you are going to do is, to do this, you need to put that table, but not including the totals. So you're going to completely take out the total column and the total row. Okay, we just want the table that has male, female, and the salaries. We don't want any of the totals in there. And then you go into your calculator and you need to go to second, and that button that says X inverse on the far left hand side, it's about the fourth button down. Okay, so second and that X inverse button, it's the matrix button. And what you're going to do is to go over to edit, and you're going to edit any one of the matrices that are in there. So you can put this into matrix A, B, C, D, it doesn't matter. Okay, just remember which one you've put it into. So in this case, I've got 4 rows and 2 columns. So my matrix is a 4 by 2 matrix. Okay, so I'm going to put in these values. So I've got 36, 68, 54, 43, 42, 31, 23, and 19. Okay, so I put those values into my matrix. So I've got 2 columns and 4 rows. I then have to go to second and quit. So I have to quit out of that menu. Then you're going to go to stat and across to tests. And you want to go down to option C, which is the chi-squared test. Then it will ask you observed and expected, and then you can go ahead and calculate this. Your observed matrix is the observed values that you have just put into that calculator. So whichever matrix you put those values into, that goes in as the observed matrix. So you'll have to go into like second matrix and select that particular matrix. So you can go to second, that X inverse button to go to the matrix menu, and select whichever one under the names menu, you select whichever matrix you put those into. For your expected matrix, put in any other blank matrix. Okay, you don't have to type in anything. All you have to do is go back to that matrix menu and select any other blank matrix. Okay, it can be B, C, D, E, F, it doesn't matter, as long as it's not the same matrix that you just put the observed values into. What this is going to do is it's going to calculate those expected values for you. Okay, and then it's going to input them into that matrix. So each one of the expected numbers for each of the cells, it's going to put those into the associated cells in that matrix. Okay, and then you can go ahead and calculate. Now, first things first, on the screen that comes up, it will give you chi-squared, which in this case I get 13.02. That is your test statistic. Okay, so if you wanted to compare your test statistic to your critical value, that is that value. And then I get P is 0.0045. And then if you carry on, I actually get 0.00459. So I can compare my P value now to my alpha value. I can see that P is less than alpha, so I'm going to reject my null hypothesis, which means that I can see that there is a dependence between salary and gender. As P is less than alpha, so salary and gender are dependent. Okay, they depend on one another. Okay, now what you can also do, if you look, it gives you your degrees of freedom, which was the number of rows minus 1, which was 4 minus 1, times the number of columns minus 1, which is 3, multiplied by 1, which is 3. So I've got 3 degrees of freedom, and it calculates that as well for you. The other problem that you will get on Hawks when you go through these is it will ask you for the expected number that was to go in a particular cell. What you can do, if you quit out of that menu and go back to the home page, go back into the matrix menu and click on the particular matrix that you asked to be your expected matrix. Okay, so whichever matrix you pick to be your expected matrix. Click enter on it and click enter again. And then you will get this matrix come up on your calculator. No doubt it will be decimals. Okay, there'll be a lot of decimals in there. And each one of those cells corresponds to the expected number that they expected for that particular cell. So if I look at this, my top left entry in this matrix is the number of expected males that they had that earned below 25,000. So how many males did they actually expect to earn less than 25,000? And it tells me on here that I've got 51.01. So roughly 51 males they expected to earn less than 25,000. So you can go ahead and look at this matrix and it will tell you how many they expect of each one. Okay. That is the end of the chi-square distribution. It's actually the end of the videos. If you have any questions, please let me know. I will be more than happy to help, and let me know if you need any help with your review.